Hello. Hey, hi, folks. Good evening. Hello.
Hi, Blush.
Hey, hi. Sorry for being late. I think my Zoom just keeps troubling me.
Oh,
Anyway, a very good evening to everyone. How are you doing today?
yeah, good.
Okay. Uh, all right. Do we
Hi,
have?
Abhilash. Hello. Can you
Hey,
hear me?
hi.
Yeah, hi, Abhilash. I'm so sorry for the inconvenience. I'm at college right now. Just now I completed my class. So I'll
Okay.
be traveling to back to my home. I can't respond in the class, but I listen. I'm in a mobile mode. I
Yeah,
listen to
no
the
worries.
class. Yeah.
That's all right.
Thank you. Yeah.
For the heads up. No worries. Okay. I think we have full house. Let's get started. So let me start by asking, like, do we have any doubts or any questions from yesterday's or last two sessions? Anything from the last, any questions, anything on your mind, you want to discuss anything? Let's take like the first 5-10 minutes to kind of go through that. All right. Okay, seems like we're good from the last two sessions. So just to recap, I think we just went through select case from where group by having. That's pretty much what we did. And then we did subqueries, right? So let's start by, with Gautami. So Gautami, can you share your screen? Let's begin by getting some questions out of the way.
Yes, sir.
Okay, so does anyone want to take a shot at asking, like beginning with the first question? Come on, I think you guys must have practiced. So any question that you felt was interesting yesterday, or you felt like, okay, let's, you found it was difficult to do. Maybe we can begin with that.
When I was doing some exercise, I found some null values.
Okay, all right. You found some null values.
Yeah,
We'll get to that. That is fine. So basically, that's part of data cleaning in a way. So that's good that you found them. We'll have to handle them somehow. Okay. All right.
yeah.
So let's begin with this, Gautami. So we want to know the average scores that students scored in all the subjects, but we are looking for only students who are of age 13. Is the question clear?
Okay.
So we are looking, just let me just repeat that. We are looking for students with age 13, and what is
Okay.
the average marks that they got in all the four subjects, right? That's the question. And just to kind of give you some heads up, you'll need to do like a subquery in this thing, right? So
Okay.
let's take 5 minutes to kind of solve that, and everybody else, you can try this as well. Okay, let's start. You can think out loud. You can discuss with the class as to how you are approaching it. Uh, we can help you as and when needed.
Okay. So first, I think I will check the everyday score. Then I will go to the age.
Actually, can you write down what the output should look like first? Just simple.
Okay. Yeah, so we have to get the average score of all the subject and the student age equal to 13. So,
Okay, so what is the first thing that you will figure out?
I want to check the average score
Okay,
in
so you want to
the
get the average
inner
score first.
query. Yeah, so in the inner query, I think I will check the average score.
Um, Actually, let's do it different, right? First, you need to figure out the population that you're looking at, right? So you're looking at students with age 13 first. That is your
Mhm.
base, correct?
Okay.
So let's
Yeah.
start with figuring out who are the students. How do you get like students with age 13 first?
Okay.
Okay, so you got the students, right? Now, what do you need? You need, so you got star here, correct?
Yeah.
So, okay, that is fine. So now, what is the other thing that you want? You want average
Average
scores
score.
across subjects, right?
Mm-hmm. Yeah.
So just write first average score across subjects. Keep this query, just write another query which
Okay.
just gives you what's the average score across subjects. Can you figure out what the error is?
Yeah. Table.
Okay. Can you put a semicolon in the first line after the end of after 13? Let's try running the second part. Just run the selected query.
This one?
Yeah. So
Yeah, I
right click and
received the
run.
key.
No, just right click and run selected query. Okay.
Oh.
So you got here, but you got only one subject, right? Why is that?
Mm-hmm.
You should get 4 subjects, correct? What are we missing?
Group by subject.
Correct. Yeah. So it's group by. So always when you are using an aggregate function, you need to group by. If you have a column, let's say if you did not write subject there, then you don't need to group by.
Mm.
You have to always yeah, I mean, this is one output. So if you scroll down, maybe like comment query number 1 either. So it is running both the queries basically. Yeah, now you can run it.
Okay.
Okay, so you got this.
Mm-hmm.
Now
Mm-hmm.
what is the step? You this is for all the students, right?
Yes.
So you need only students with age 13, correct?
Yes.
So assume that you have age in scores table. How will you filter out only students with age 13?
So the first query, student
No,
where
so let's
age
assume
equal to
that.
13.
So yeah, that's fine. But so okay, so write a where clause.
Here.
Yeah, but where clause is always before, after, from, and before group by, right? So it
Yeah,
applies on the
select
table.
from score. Yeah, where.
Okay.
Select.
Okay. So can you run this?
Yeah, we don't have age column in scores, right?
Correct. So you don't have age, right? So you now need to get what columns do you
Okay.
have in the table? You have ID, name,
Subject and
subject,
score.
and score, right?
Mm-hmm.
So what you need to now, you can only filter on ID or name, correct? You need to get a list of students who are 13, correct? In the first query. So just run the first query now.
Okay.
So here you have student and age, correct?
Mm-hmm.
So you need to basically in the second table just select these students, correct? You already have a list of students with age 13.
Okay.
You need to select them. Okay.
Mm-hmm.
Okay. So first of all, in the where clause, you don't have age. So what do you have? You have ID, correct?
Yes.
So you need to filter ID. Okay. Now, if you do ID is equal to one of the IDs that you see on the right. So ID number 1, Brawny is basically 13, right?
Mm-hmm.
So if you do ID is equal to 1, what will you get?
So the first row.
No, you are doing it on the scores table, right? Run it, see what happens. So you got the scores, but you see the scores are different now. Correct? Average scores.
Yeah, yes.
Why is this? Like, who are these scores for?
Yeah.
Who are these scores
ID. Whose ID is 1?
Exactly. Whose ID is 1, right? Now, instead of 1, you need all the IDs that you got from the first query, right?
Mm-hmm.
So just let's do one step further. Let's say ID in something, right? Let's say ID in right? Brackets.
Mm.
Just say 1. Okay. What other IDs were there? Can you run the first query again? See what IDs were there? So what is the second ID that you did take?
12.
These all these IDs, right?
Yeah.
Okay. So let's
Mhm.
put some IDs manually first. So let's do one, whichever are here, right?
Mhm.
Okay, that's enough. Let's try and run it.
Okay.
Now you put 4 IDs,
Yeah.
correct? Let's run it, see what happens. So now you're getting for how many IDs?
For 4 ID, 1, 12,
Okay,
14, 15.
makes sense. But you cannot do this for manually for all the IDs, right?
Yes.
So how do you do it now? But you have the IDs in your previous query, right?
Mm-hmm.
So instead of the manual IDs that you have written, you just need to put the
Mhm.
subquery there, correct?
Okay.
So
Yeah.
let's do that.
Yeah.
No, you see again, what you did was you replaced the where clause. You only have to, your query was correct, right? You have to say ID instead of ID. Can you go back? Just press Control Z.
Yeah, it's not coming.
Yeah. So this code is the same, right? Only manually what you are typing, the IDs, instead of that, you will take it from the query, correct? So instead of IDs, the manual IDs, you should just type the query. So in the bracket, just write the subquery, right? This is exactly the subquery.
Yeah, so I will write the select ID from the table name.
Yeah, exactly what you wrote above, right? In tile number 1.
Okay.
But instead of star, you just need one, which is ID.
Not this course table, because course table don't have, not from this course table.
So Gautami, just copy line number 1, right? In line number 1, you got, just copy line number 1. And instead of select, you are missing an S. Yeah.
Yeah.
Okay. Just remove the semicolon after 13. Perfect. Right? Let's run it. Okay. So you got the answer. So did you understand the steps like what we did in the middle?
No, actually.
Okay. All right.
Okay, ID and select.
Okay. Let's go back to the previous query. So sorry, did you get it?
Yeah, I got it now.
Sure.
So yeah, whose age is 13? Okay.
So did you understand the first one where you put the IDs manually 1, 5, 13?
Yes.
So basic fundamental is instead of manually putting it, you will put it programmatically. That's it. You'll put a subquery in the where clause,
Yes.
right?
Yes.
Okay, so let's do one more thing. So now what you did was you had you got age is 13, correct?
Yes.
Now I want whose age is 13 and who are in section C. Only students with section C.
Age
So
13
age
and
13 and
section
section,
C. Okay.
correct. How will you do that?
I put end year.
Okay, makes sense.
Section C. No output.
Check why is that? So whenever there
I
is such
think
a
no
problem
one
where you
is there.
okay, but okay, so let's check the let's run the first query, right? The one in row number 1.
Okay.
Let's run that. Okay, let's run it. So you see, the first itself is there, right? You have Brawny with age 13 and
Yeah.
section C. So why is it not coming?
Use uppercase C, Gautami, not the lowercase c.
Okay.
So essentially, all your where conditions are case sensitive. Small c and capital C are different for them.
Okay.
Okay, all right. Cool. So, okay, are we clear on this? How we are using subqueries?
Yes.
Okay, if there is any doubt, we can still clear it, right? This is how basically we need to practice, but this is
Yeah.
how we clear it.
Practice. Yeah.
Okay, all right. Let's do one more case here, maybe. So let's do. So yeah, so we want to get only students whose ID is between 100 and 150.
ID is 100 and between 150.
Between 100 and 150.
Okay. From the scores table.
No, actually, yeah, because there is an ID there as well, right?
Yeah, in
Yeah, sure.
both table.
Let's figure out IDs. Okay, let's do it that way. Let's figure out IDs from the students table. Let's get IDs from student table and then use it on scores table. Use a subquery to do that.
Okay.
Okay. Okay, that's fine. So in between, you don't need the brackets. So you can just say 100 and 150 space. Okay, so this is your subquery. What do we do with subquery?
What was the question?
So I just want the average scores by subject for these students that you have selected in line number 9.
Every scores.
Yeah. No. So you have already written the query up in upstairs in the upper lines, right? 3 to 6, correct?
Okay.
Instead of the subquery there, you just need to replace it with this IDs, right? So think about it this way. What you did was you calculated the average scores and you filtered it by IDs that you wanted. In the first case, you wanted IDs where age was 13 and section was C. So you wrote that subquery,
Yes.
correct?
Yes.
Now, in the second case, you wanted IDs between 100 and 50. So you wrote that subquery.
Okay.
You just need to replace the subquery.
Yeah, here.
Yeah. Okay. Let's run it. Where ID is not in, it's just between. Line number 5,
Okay.
ID is ID between. I think it might be is between, but let's see. Let's run this. Okay, you got it. Okay, you understood this?
Yes.
Okay, all right.
Okay.
Cool. So thank you so much for that. Now
Yeah.
I'll share the screen and we will. So this is a very crude way of doing things, right? So you can see my screen. Okay, I think my editor just closed. Give me a moment. That's not correct. So it's here. And we need to make this and just do this. Okay. All right. So let's do joins. Okay, how many of you are familiar with joins? What is happening here? Okay. Okay, so I'm guessing few people are, but that's fine. Let's get started. So this was a very inefficient way of doing things, right? I mean, let's say why? Okay, so let's say that you have millions of rows now. You will put like, think of your query, right? You'll have to write, the select will give you like millions of rows, and then the where condition will filter through all the, all the IDs in the list. So we don't really want to do that. So there is an efficient solution for it, which is joins. But before we go there, I just want to highlight one more quick thing. Why is this getting freeze? You can see my screen, right?
Yes.
Just freezing for some reason. Weird. Okay, now it seems to be working. Okay. All right. This seems to be the culprit. Got it. Okay, so before we move, I just wanted to highlight one more thing. So we did the same thing, right? In subqueries, which is subject, and we did average of score rather, as average scores. Again, let's follow best practices. So scores, and what are we doing? Where ID is in select ID from students, where I'll just do age is equal to 13. Okay, and excuse me, group by one.
ID in. ID in.
Okay, thank you. So we get this, again an error. Students, I think I misspelled it. Okay, we get this. Now let's say that, so there are other ways. For example, you have two variables you need. In this case, ID is enough. But let's say you want to do it on ID and name. You can put the ID and name like this. So what we are saying is, I want ID and name to be, but there needs to be an ID and name here as well. So you pull two columns from here in the subquery, and you check both the columns here, right? That's the only difference. Of course, there is no change or no difference here, but I can show you like this. If I do a select star, this thing, no such. Did I? Why is this not running? Yes. Okay, I think there's some issue with my. Today, let's reload this. Okay. There's no such table called as scores.
Oh, I think you have choose the another database, I guess. Can you check the database?
I check that, but both of them should be similar in my
I
case.
choose database. Yeah, the second one, I guess. Is it correct?
Both of them are same though. I mean, we can try with that. Maybe what is happening is your okay, let's try only this and see if this is giving me something. All right, seems like a so let's try this SQL viewer, open database. So open this. Let's see if it works now. You have the scores table and this thing here. So technically it should work. No problem. Let's reload again. Okay, control shift P, write open a database. Let's do the data. This thing, this also has similar, if this doesn't have any, maybe it is getting confused. So I'll just delete this. Don't need it. Then we will just look at the schools DB. This seems to have it. Okay, control shift P, open database. Okay, here I have the tables. So okay, so let's run this. Okay, it's working now. Weird. And sometimes. Okay, so this is what it is. So if you look at it, okay, I don't need the group by here. So this will work as well. So you can just add any number of columns here. So let's say I want to add age as well, and if age is here, it will work, right? Of course, age is not there in scores table, but this is there. So just wanted to highlight that. Is it clear?
Yes.
Okay, all right. So let's move to joins now. So joins, as always in SQL, is just joining two tables. Okay. So I'll take just one example. Let's filter. Let's select everything, and let me sort by name. Right. I don't know why my system is behaving weirdly. It's not sorting. Okay. Here it is working. When I'm telling it to maybe like it is this. What now? Okay. Okay, so I got the students, right? So let's take just one student, which is actually, let's take two students. So we have in one table, what we have here is, so this is my students table, right? Let's assume there are just two students. And then I have my scores table. So let's just pick two students, right? Bronny and Lemmy. So I will clear everything and say Bronny and Lemmy, right? Actually, let's take one more. Let's take Abel as well. So we have this. Okay. So this is my other table, let's assume. The rows are reduced, but not a problem. So this is my scores table, right? Okay. So and just for clarity's sake, let's take one more, student here. Okay. So we have students table and we have scores table. So two tables that we are working with. In the first table, we have Bronny and we have Lenny and Danya. So three students. And in the second table, also we have three students, but the student is different, right? So Abel is another one. And as you can see, Danya is missing. So what does joins do? Join is very simple. Join will look at, let's say you want to find all the Bronnies in scores, correct? So let's look at the syntax first. Okay. So we'll say, so we have two tables now because we are joining two tables. So let's take a base table. So, and our problem statement is the same that Gautami solved, which is we want to look at the average score by age, right? So by 13, like whatever, 13, 14, 15, we want to look at average scores by age. So first we need to join the two tables. Which are the two tables? So we have students, okay? And now we need to merge or join the other table. So I'll just say join. The other table is scores, right? So I got these two tables. What am I joining on? So joining on is the common IDs, right? So ID and name is common here. So let's take ID. So what we are saying is join on where student or students.id is equal to scores.id, right? So wherever this is happening, just kind of return me everything, and this is the syntax. Let's try and run this, and we'll see what happens. So look at what you got here. So you got a combination of both the tables. The first 5 rows are from students table, and then the next 4 rows are from scores table, right? And as you can see, the columns are repeated as well because they are common in both the tables. Okay, so now this is syntax. Let's figure out how this works. So we said, give me all the students from the students table. So it took row number 1. And what is the join condition? It is looking for student ID is equal to scores.id. Okay, so it will take first row. So I will just demonstrate how this works, and then we can take it forward. So the final table, it will take the first row. Okay. Now it will look for the ID in the second table. So here the ID is 1. All right. So it will go look for ID equal to 1 in the second table. And wherever it finds a match, it will pick up all these rows and it will paste it in front of this, right? So it's essentially, this is how this table is created. Okay. So this is the first match that it got. Then it will look for, it did it with the first row, then it will look for the second row. So it will paste the second row here, or it will start with the second row. Again, we are matching it on number 2. So it will look for the student ID is equal to number 2. And it will pick up all these rows and it will put it here. Okay. Then what it will do is it will look for third one. And of course, third is not here in this, so it will not paste anything. It will all be blank or null, right? So, and once it does this, it will just duplicate these rows for it. Right here, there is nothing, so this will be null. Are we clear on how this is working? Are we clear on how joins are working? Did people get a sense of how it is working?
Yeah, I can understand that.
Yeah.
What about other folks? Okay, let's try and replicate this in the tables now. Okay, so I'll go step by step. So my first table was, I'm selecting everything from students, and what is in the Google sheet that we have, the ID is 1, 2, and 3. Okay, so I'll just select a subset of this, which is 1, 2, and 3. Let's see how this, if we are able to replicate it. Okay, so you see we got just 3 students now. So this is the set that we're working with. And we have 3 students here as well. So this is my first table. Now let me put my second table in. So here also, I'll just do a select star from in scores. This is just for demonstration purpose. You don't really need to do this, right? So here the ID is in 1, 2, and 11. Okay. So let me run both of them. So as you can see, we got these 2 tables. Now let's join them. So what we are saying is, actually this is the query itself. So let's kind of do this. So instead of, and here I'm using subqueries, right? So just for, again, for demonstration purpose. So I'm saying from my first table, which is this table on the right hand side, top right hand side, join the other table, right? So I'll just name this as ST. maybe like C scores. And because I've renamed them as the student ID and scores ID, and look at, and let's see what happens now, right? So let me move this. So as you can see, wherever it was a match, it found it, right? So it says Bronny and Lemmy are a match on IDs 1 and 2. So you got returned 1 and 2. Dania is not a match, so it was not returned. Okay. This behavior is essentially called inner join. So there are multiple types of join. Here we get only output of only where there are matches. Okay. Let me try and get what we had in the Google Sheet, right? So if we do a left join, you can see now Danya is returned with null values. Why is that? In left join, the first table that you are giving, it becomes your base. So this is my base. Whatever matches, it will match and it will append, and whatever is missing, it will just append null values. Is this clear?
Yes.
Everyone else? Prinsa, Sai, Ayushi, Sulabh?
Yeah,
Yes.
Okay. There are 4 combinations here, right? You have 2 tables, so there are 4 combinations. We have seen 2 combinations. The first one is left. So what it does in left join is the first table that you give, that will become your base table. So all the rows there will definitely remain. In inner join, only it's like a Venn diagram, right? Only the common rows will be there. So there are 2 more combinations. One is outer join. Here, everything will be there. So if you look at it, where did we? Maybe 1, 2. It's not returning, so maybe I'll just need to remove this. Okay. It just did not give anything, right?
3 is missing.
Okay, it's not supported basically. No, that's fine. So in SQL, right? So there are 2 other type of joins, which is outer and right join. SQL doesn't support it, and SQL Lite doesn't support it. And the simple reason is that generally you will not use them in any kind of your work that you are doing. So in general, like in 99% of cases, these will be not there. So essentially it's not supported, but I can just demonstrate that in the Google Sheet here, right? So, all right, so this was this is an example of left join, right? Okay, before we move there, I just want to quickly demonstrate one thing, and then we can, look at all the other joins. So here we had, what we are seeing here we are seeing duplications of IDs, right? Columns. We don't really want that. So here is where naming helps. So you can tell them that, hey, I want st.id, I want st.name, st.gender, and then you have st.age and st.section, right? So I'm specifying what columns I want. And from the scores table, I don't really want ID and name. So I will just take st.subject, st.subject, and then you have st.score. Okay. So let's see what happens now. So see, in the first one, in the left join one, you got only subject and scores, and in the the inner join one, you got subject and scores and ID and name. So think of it that this is the first, this table is created first, and only then the columns that are needed, they are just chosen from this table. Is it clear? Folks, is it clear, the difference?
Yes.
Okay, all right. If anybody has any questions, we can solve them. It's an important topic. It will, like, this is itself is what we're going to discuss today. So if there are any questions, feel free to kind of ask. The other quick thing that you can do here is, instead of writing everything as st dot all the columns, because we are taking all the columns, you can just do st dot star. What it means is all the columns from the st table and only 2 columns from the sc table. This will work, similarly. Comma is missing. So as you can see, it works similarly. Okay. That is all I want to demonstrate. Let's just quickly go through the types of joins. And once that is done, we'll come back to the problem that Gautami started, right? That's all today. So this essentially is your left join. Okay, can anybody explain why this is a left join?
Because it takes all the rows only from the first table.
Correct. So from the first table, and first table is essentially the left table in a way. So basically it's a left join, right?
Yeah.
Okay. Now let's do the other type of joins quickly. Okay, messed it up. All right. So let's do an inner join. What will inner join do? Inner join will just take all the common elements. That's it. Okay. So this is what you'll get in an inner join. Let's do a right join. So what happens in a right join? Can somebody guess?
I think it left out 3 and add 1, 1, 1.
Correct. So this, let me just color it. So this will become your base now. The right table, which is, or the second table, which is the scores table. So 1 and 2, it already found a match, so there is no problem. Then it will go look for one by one all the rows, right? So it will look at this row. It doesn't find a match, so all these will be null. Similarly, it will go look for other 3 rows. Again, it doesn't find a match, so it will be null. Okay. Let me reduce this. So you'll again see nulls here, but it will be on the left of the first table. So ID number 3 or that student will be left out. And of course, there is the fourth one, which is outer join or full outer join, as some of the systems might call it. And can somebody guess what will happen here?
Gives all the values in both tables.
Exactly. And what you will see here is 2 types of nulls. For student number 3, you will see nulls here, right, on the columns on the right hand side. Okay, just border it. And for the student 111, you will see nulls on the first side of the table. Okay, this is your outer join. I mean, it's called outer or it's called full outer, depends on what you're using. Okay, did you understand what is happening here?
Yeah.
Okay, all right. Now let's try to solve the question that we started in the beginning. We want average scores of students of age 13, right? So that we'll start with that first, and then we'll extend that to get average score of students by all the ages. Okay. So what are the steps here? The first step is we had these two tables. Okay. The next step is we want to create a table, right? We want to create a common table which has both age and scores. So currently, what's the problem? The problem is we have scores in one table and we have age in another table. So we want to get to a state where we have all the data in one place. So what we will do? We will do join, right? So here we'll create a join, which is a common table. So we did a left join now. Okay, now I have this table. And from here, our steps are simple. What will we do? Now assume that this is a table that we have and we want to get average score by age in each subject. What will we do? So forget everything before step 2, right? We already got join. We have this new table now. Okay. From this table, if we want to get the average scores by age for each subject, how will we do it?
We apply filter. Age is 13
Okay.
to get the average of score.
Okay, so we got filtered, so average of scores. And after filtering, what will we do?
Group by subject.
Yeah.
Exactly. It's the same thing, group by listing, right? So essentially, we do the same process, but instead on one table, now you're doing it on a common table that you created, right? So that's pretty much it. So here you'll group by, filter and group by, right? So step 3 will be your filter or where condition. Okay, so this will pick up only Brawny because you have your age 13. Okay, and once you have this, it's the same process, right? You will group by. What are we grouping by? I mean ID or a name, so it doesn't matter. So let's do an ID. So 1. What are we grouping?
Subject.
Subject as well. Actually, we are grouping by subject and not by ID, but that's fine. Actually, let me just take an example where this is also, let's look at 13 and 14, 13 and 15 both, just for the sake of the example. So it will take both of them. Okay. Or actually, let's not do this. Let's take 13 and 14. So it will pick up this row as well. Now what will it do? It is looking for subject. And here it will take all these rows, unique rows or unique combinations, and it will say that, okay, for this guy, it is 20, science is 21. So here, because there is just only one row, let's take this for completion purpose. So for science, it is now 21 and 29. Okay. For English, it is 41 and 81. For history, it is 62 and 17, and then 49 and 40. Okay. So these are my scores, and what it will do is an average of scores. So 29 plus 27, like whatever this is, right? It is 50, I guess 25. 122, so seems like 61, 79, so half of that, 39.5. And then this is also 89, I'm guessing 45, 44.5. Okay, so this is how the final outcome will look like. You clear on this?
Can you explain it again, the second, like the step 3?
Which is the where condition.
Yeah.
So in where condition, we said that we want, with age 13 and 15.
Mm-hmm.
So this was your first step, which is your raw tables. You joined them. So that you got a new table now, essentially. On this new table, you're saying that I want to filter them. Only I want rows where age is 13 and 15. So we'll get 13 and 15. This row, this student, Danya, will be left out. Correct? So on this table, we filtered it. We got these rows. And now, once we have the filtered rows, it's just a matter of grouping by, right? So we group by subject. So science, it will take science here and science here. So it will pick up two values, 21 and 29, so that you see here. Similarly for English, history, and maths, and then you average it.
So what kind? So if there's another question similar to this, what kind of join do you recommend?
See, what kind of join depends on the question that you're solving.
Mm-hmm.
Generally, the best practice from a problem or an analytics perspective, I'm not saying from an SQL perspective, is first figuring out your base. So in this case, my base was all students with age 13 and 15, right? So that is my table number 1. That is my left table. Suppose that on that base population, we can find different properties. Okay, so then you will do, if that is your base, like in a problem where, let's say, okay, think about it this way. You're looking for students who went from Asia to US to study, correct? And you want to look at what is their average, scores in this example, same example. So what you will do is you are only interested in students from Asia. So that will be your base. And then on that base, we'll do a left join. Why? Because you don't care about other students who have come to US and they will get missed out, that is fine. But you care about all the students that went from Asia. So in this case, let's say Danya is the person whose scores are not available. So you should know this, right? From a business perspective, you should know that one student is missing. Like we don't have the scores for them. So you will use a left join. Okay. But let's say that now we are looking at students. There is a problem statement where really don't care about Danya's score, because whenever a score is absent, we assume that she did not appear for she did not go to the US at all. She qualified, but she chose not to go.
Okay.
And that is why the scores are missing. In that case, you will just use inner join. So what join to use depends on what problem you're solving.
Okay.
As simple as that. Okay. And in most cases, you will use a left or an inner join. There are rare examples where you will use outer join. Very rare, right? And right join doesn't make sense, because if you are using right join, you just swap the tables, right? And you say that I'll use a left join. Correct?
Yeah.
Right join is nothing but a left join with reversed order.
Yeah.
Correct? So, and intuitively, it is better that you say that, okay, this is my base population. And on this base population, I will figure out whatever, properties I want to find.
Mm.
Okay.
Yeah. Okay.
Does that answer your question?
Yeah. Yeah. It does. Yeah. Thank you.
Let's try and do this now in SQL on our tables. All right. So let's see what will happen. So we will remove all these subqueries. We don't want them. Let me start fresh. Cool. So what we are saying is, so to answer your question, how will you do this? We need to identify the table first. So which is my first table? Or the left table?
Students.
Makes sense. So we got students. We need to do a join. What is my second table?
Scores.
Course. What kind of a join do I want to do? Okay, let's assume left. Okay. What are the common columns that you want to join on?
ID.
Okay, so here we are joining an ID. Okay, let's join an ID and then we can see what happens when you join it on name. And okay, so this gives you a table, right? This is now you can think of it as this is my new table. So I do a star. Am I missing something? Okay, so you got this is your new table, correct?
Yeah.
What did we want? Now we want now because this becomes my new table, or let me go one step further, right? I don't want all the columns from scores, so I'll just take scores dot subject, and I will say scores dot scores, right? These are the only two columns that I need. Okay, so I got my, think of it as my intermediary table, right? Now we want to filter. So this is my table completely. Now it becomes simple. It becomes as it is, right? So we say where, what is the filter on? Age was 13. So where my student dot age is equal to 13. Let's see what gives you. See, now you're getting, before you had 1005 rows with all 13, 14, 15, right? As soon as you put a filter, you're getting only 13. Okay, so this becomes your table. Now let's go one step further. I already have this table. How can we do this? So this is my table now, right? This is my intermediary table. Let's write a subquery. So this is my table now, from which I will select. What will I do? I need to group by, right? So I need to group by subject, average score, as average score, and group by 1. See, you got your answers. And because, like Shanti was saying, we'll investigate the nulls, but because there were some nulls, you're getting null as a value as well. Did people understand what is happening here? This, by the way, is same as this. We did this yesterday, correct? So think about it as, instead of grouping on the scores table, you created a temporary table, which I'm putting here in a subquery. And on that table, you're grouping, right? So just scores is replaced by this intermediate temporary table. Are we clear here?
Okay. It's a temporary table. Okay.
In a way, right? Now SQL does it one step further for you. I mean, it's not a temporary table, but it's a way to understand that it's a temporary table. Now, what SQL does for you is that you really, in joins in specific, you really don't need to do this subquery. These columns are available to you here itself. So you can do directly on this, you can apply your subject and score, and you can just say group by one here again. And this will give you the same answer. Okay, so this subquery, the way we do it here is we did it by subquery. Here we did not do the subquery because this itself will return you the table, and on that you can directly apply the group by. Both of them are exactly the same. The below one is slightly more efficient. That's it.
Yeah.
Okay.
Yeah.
Complete the SQL, syntax for select everything here. And what is missing? So we got select, we got from, we got join, we got where, we got group by. What is missing is having. So I want to look at only scores greater than 50. I get only scores greater than 50. And the last piece is I want to order by my average score. So I got it ordered in ascending order. This is all you need in SQL. That this is the entire SQL select statements covered. If you just practice this, like 85% of your job is done. Okay.
Yeah.
All right. We learned one more concept yesterday, right? What was it?
Yes.
Yes, exactly. So let's do that. So right, and currently there's an error. Where is it missing? It says S dot Acha, I did not replace this. So here you got this as well, where subject is arts in a category for math and science, right? This is everything that we learned so far. Folks, any doubt here? Anything? I will paste this in the chat so that you can use it as a reference and practice. But yeah, I'll just pause and yeah, go ahead.
I have a question. In the last output, why did it show like English, history, and math as sciences, but not the science?
Oh, because what is the average score of sciences here? 48?
Mm-hmm.
And we have said that we want average score greater than.
Okay, 50. Yeah, I get it. Okay.
So we have filtered it, right?
Mm. And how would you like the same thing, but how would you just give output for arts and science, not separated by history, or like not separated with the
Yeah, you don't. So you basically are saying you don't want subject, right?
yeah, just the subject
so,
category.
yeah, so don't use subject here.
Mm.
Okay. I will remove subject from I will not select subject. And because I am using only category, I need to group by only subject category.
Mm-hmm.
There,
Oh, okay.
right? I think that's just that's an interest. Slightly, it helps you understand one more thing, which is uh, what is happening here, right? So let's, okay. Laptop just behaving weirdly today. So here, what it did is it actually averaged out these two as well.
Mm-hmm.
So sciences is there, arts, it just averaged out these two.
Yeah.
Okay.
Okay.
And because you brought it up, let's do ID as number of students, but it's not ID, it is
Distinct ID.
distinct ID. So now you can just keep adding because you got your structure. Now the interviewer can ask you anything, right? And it's very easy for you now. You got your structure, you just need to add your aggregate functions. So they want average, you give them average. They want count, you give them count. They want max, you can give them max. Minimum, you can give them minimum. Let's look at, yeah, so this is there. Let's see what it does. Okay. Okay, so this is giving me an error. Why is this? Can you someone explain?
We should
So it's
give the
telling you that.
allies or something there.
So basically, the point is ID is common in both tables, right?
Yes.
ID is common in it is there in student and it is there in scores. So SQL doesn't know which ID it should pick. It is our job to tell them, and hence we have to say whichever, right? So I'm picking scores. I actually because your left is best practice is to pick from the left table because it's an ID column. So we do students.id. That's it. So if you look at 50 and 51, right number, I can do score because score is just one column. It is not common across both. So SQL doesn't have a problem. But whenever the column is common, SQL needs to know which table it needs to pick it from. So now you have it, right? So you got 82 students in sciences, 82 students in arts. Similarly here, English, history, maths, and that's okay, I'll pause here. Any questions? Okay. One last thing. On and where conditions are similar. Where if you want to, what do you do when you want to put more conditions in where? You do an and clause, and condition, right? You say and. Similarly, you can do it in on condition. Let's say you want to join on multiple conditions, which is students.id, and I also want to make sure that the names are same. Name. Right? So you can just keep adding conditions like this. Oh, sorry, I need to put and, right? So similar as you do in where conditions, you can do it on conditions.
Okay.
Okay. And of course, you can do here or as well. So you want a student to be 13 or in section A.
Mm-hmm.
You can do and or, all these combinations are possible. Okay. Any questions, folks?
One question. If there is a possible of getting the required output by subquery or by join, which one is suitable to use?
Joins are always efficient, and we should use joins. And if you look at the previous, like the example that we did here, right, which is the subquery one.
Mm-hmm.
So there are, I mean, the simple answer is that you should use join first of all, okay, because it's more efficient. SQL has, you know, inbuilt functions to kind of do that. Like it is optimized for, you know, doing that. Here, if you look at, so here we got the same thing, right? Which is, did I, okay, this is also join. I don't want to do join. We wrote a subquery, right? I'll just write one, not a problem.
No,
So,
in a different sheet. Yeah.
yeah, so we did this, right? We said that get me all the scores where the ID is in select ID from students, where age is equal to 13, correct?
Yeah.
So this is what we got. And of course, here now we can do the same thing, which is subject, comma, average of score as average score and group by 1. So we got the answer here, right? We can do everything. But the problem is in the scores table, we still don't have the age, right?
Mm-hmm.
So if in this case, if we wanted to get age into the picture, we can do that. So in joins, because it's a temporary kind of a temporary table or a, you know, transitionary table is created, you can do here age is 13, correct? So now age will work. And for example, if you want multiple of this, right, which is in, let's say 13 and 14, see, it will give you 13 and 14. So you can compare it right here. How is my 13 science doing versus my 14 science?
Mm-hmm.
Correct? But if you have to do it in subquery, you can't do that because you don't have the age column. The way to do it will be, you will have to first do 13, note down these answers, then you'll have to go back, you'll have to do 14, right?
Mm-hmm.
And then you have to run again, and you have to note down, and you are not able to see here whether it's 13 or 14, right? So this might lead to confusion and errors.
Mm-hmm.
Correct. So that is the reason joins are better, always better, and of course they are much more efficient. So if you look at the runtime, they'll probably be like much faster than subqueries.
Mm-hmm.
And you don't see the difference here because the data is small. But if the data is in millions or even like hundreds of thousands, the runtime can be very different.
Mm-hmm. Thank you.
Okay. All right. Any other questions?
I have a question. It's not related to this part though. Should I ask?
Go ahead.
Or wait?
Yeah, go ahead. Go ahead.
In our data set, there is only first name, right? So if there was like last name too, for example, like I see Bronny plus a last name in the same column, and you are given that extract the score of Bronny but there could be multiple Bronny, right? So how do you do that?
Yeah, good question. So let's look at it. So we actually have that example here. So let's say we did yesterday, we knew that there was Dory was repeat, right? There were two Dorys in the class, correct? So let's do this. Actually, Brienne was also repeated. Okay, so I'll just create a new sheet. So let's assume that this is my table, my students table now. And actually, just for the sake of it, let's add, someone who is, okay, because we are getting into that territory, let's do Donald, let's do many. Okay, so let's assume that this is my students. I only have these many students. So this is my students table. Okay. Now in my scores table, so I've got Dory, Brian, Abel, Donald, and many, right? So let's go. So I have Abel. I don't need Tony, Brian. He's not here. I'm guessing. Mickey, Donald, and Dory. Okay, so we got Dory, Brian, Abel, Donald, and Mickey. Okay. So this is my second table, which is my scores table. Okay. Now what will happen to your question, right? So here we don't have two names, like first name and a last name, but we do have people with duplicate with the same name, right? But what is the difference? The difference is the IDs are different, correct? So let's assume the ID is the last name, or it is a unique qualifier, right? So if you have to answer your question first, simply you can do join on multiple ones, which is student.name. So I can just say here first name is first name, and here last name is last name. So the more unique you make them, the join conditions, the less duplicates you will get.
Okay.
Okay. So let's look at it here. So let's say that I am first joining it only on name. So my join condition is on name. Okay. Let's look at Dory, for example, right? So here we have two Dorys. So one is, let's say, light green, the other is dark green. This is bad. I'll take other color. Maybe like fluorescent green. And you are saying that, okay, join only on name. So how will it work? It will work like this. How will the join work? It will look at, this is left join, right? So we take the first row, it look at Dory, and then in the second table, it will look for all the Dorys. So it will take these four. Okay, which are actually your which are actually the correct ones, right? They are the same color. But SQL doesn't differentiate, right? You have asked him to join on Dory, it also sees four more Dorys. So it will pick them and put it out here as well, right? But unfortunately for us, this is the wrong Dory. Correct? So you are basically getting duplicates in this case. Why? Because the names are duplicated. But the same thing, if you say that, no, I don't want to join on name, I want to join on name and I want to join on ID. correct? So what will it do? It will look for, again, it will pick up the first row. Correct? Not a problem. But now it will look for Dory and it will look for 18. Okay, let me take an example of, actually, let's not do it by ID. Let's look at it by, here the age is also same, right, for them. Okay, so let's do Brian then. That's fine. Actually, let me, okay, let's do Brian. It's easier to understand. That's the reason. These are the colors. Okay, so this is my first Brian, and this is my second Brian. Slightly different, right? So in this case, again, because there are two Brians, it will first pick the one which it sees, and all is good here, not a problem. This is what we want. But because there is another Brian as well down here somewhere, right? 146. SQL will pick these Brians as well. Okay, but this is the wrong Brian. Correct? Now, how do we get out of it, right? So if we say Brian, hey, you can add one more parameter. I want Brian whose age is 15 or who is in a similar section of section B. So if you do it on name and section, now it will pick this row. And by the way, this will happen for the other case as well. That's a good point. It will look for this Brian, correct? And it will go looking for Brian again. So it finds these four first. It will merge it, and then it will find the actual ones, and it will provide it this as well. So you should have gotten 4 rows back, and now you're like 4 and 4, 8 rows, but now you'll get 16 rows back. And of course, this is wrong. We don't want this. Correct? And actually, this is also wrong. We don't want this as well. Okay, so how do you get rid of this? You get rid of this by defining conditions properly. So now you will say that I want to join on name and section. Okay, so what it will look for is it will look for Brian and it will look for a section as well. See, so here it will go look for Brian. Actually, this is not, sorry, name and ID. My bad. Okay, and it will look for ID as well. So it sees Brian and 85. So I'll have Brian and 85, and hence it will only pick Brian and 85. Okay. And because here Brian is 146, correct? These rows will not be there. Why? Because these columns don't match. Or this condition doesn't match. Correct? So this becomes a problem. This becomes a problem. Did everyone get what is happening here? How we get duplicates and why we will, and how to resolve them?
Yeah.
Okay, everyone else? Sai, Gautami,
Yes.
Sulabh, Prinsa? Okay, cool. All right, so Prinsa, does this answer your question or it was slightly different?
This is helpful too. But my question was, okay, if you have so Brian plus last, right? in your data set, but you only know that you're extracting a Brian. You don't have like ID or anything with you. How do you extract Brian plus, like you don't know her last name yet, but the
Okay.
data set has a last name.
So,
So
okay,
how
I'll
do you
just put
extract like
your, so if I say Vivian Davis and here it's Andres, right? Let's say. So
yeah.
does the data set looks like this?
Mm-hmm.
Okay, fair enough. And you want both of them, right?
Yes, but you only
So
have,
the way, yeah, go ahead.
but you only know that you are extracting data of a student whose name is Brian. You don't know their last name. So how would you
Yeah.
do that?
So we can do that simply. So I'll just do. So it's a where condition. There are multiple types of where conditions, right? So we did and this looks like this. So first of all, let's do this. So we are looking for students. Why is this? Okay, my bad. Okay, so we have all these students. How will you normally do it? Let's say you know the name. You will say name is like Brian.
Mm-hmm.
This will give you Brian, right? But let's say that in this case you only know. Assume that BR is the first name and EN is the last name, right? So when you do the exact thing, you can say like.
Okay.
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 So that, and you can give a percent sign before and a percent sign after. Okay.
Okay.
So what it will do is it will match everything RIE,
Uh-huh.
and it can be anything before and anything after.
Oh.
Okay. So let's run this. So see, you got Brian, but you also got Sherry because there is an RIE, there is a Lorry, and there is Carrie as well. Okay.
Oh, okay. Okay. So
But yeah, go ahead. Go ahead.
does regex work in SQL?
It does. The extent of regex. So just for everybody's context, regex is something like searching within strings, right? So here, like is something like, you're looking in a string, or RIE is what I'm looking for. So this is like regex.
Mm-hmm.
With regex, you can do much more complicated things. Regex works in SQL, but it depends on which management system you're using. So modern systems like Databricks and Snowflakes, they support regex. Maybe not the entire functionality of regex that you might have seen in pandas, probably Python pandas, but it does support, the modern ones support. SQLite doesn't support it, as far as I know.
Oh,
Maybe that's a good question. I can check. Regex support SQLite.
mm. I tried.
Yeah, I don't think it maybe like it has been added. Did you try it?
Yeah, you said to practice on a different data set, so I tried in that, but it didn't work. That's why I was asking.
It looks like you can use SQL and SQLite now. Let me just quickly see if it is possible. I have generally not. I think it can be used. It seems like SQLite has added that support. I will confirm and I'll get back tomorrow if it is really possible.
Okay.
Actually, it is like, right? There is something called as expressions. I'll check and I'll get back tomorrow on this, on regex.
Okay.
But let's complete this. So this is like regex only, because when you don't know what exactly you're looking for, you can use like. And the percent, this comes from regex, right? X percent in a way. So if you look at it, I have given percent both before and after, and hence it looked at everything before and after. Why did it give zoom? But what happens if I remove a percentage after, right? So what it means is, before RIE, it can be anything, but RIE should be the last, words or last letters. So now if you look at it, Brian is gone because after RIE there is N. Whereas in Carrie, Laurie, and Cherry and Maury, RIE are the last words or the last alphabets. Correct? So what if I say that no, after it everything should be there, but before it should not be anything, right? It should be starting with RIE. So you'll not get anything because there is no such thing, no such student whose name starts with RIE. Correct? But if I do R only, see, you got all the students whose name starts with R. If I do RE or RI, you get all the students whose names start with RI. Is it clear?
Yes, thank you.
Clear for everyone else as well? So again, like this is now getting deeper into the where clause, like what all possibilities are there. So it's good. I think you guys should explore all these things on your own a little bit now, before tomorrow's class. Okay,
Yes,
so
sure.
go. And again, for reference, I am just pasting this SQL here. This has all the syntax that we have learned so far. Okay, and what you should do is try out with different where conditions. Like here we tried out with the light condition. So you can search SQLite on the internet, SQLite where syntax, and it will give you the answers, right? Try that. And the reason I am not giving you directly is because it will help you to do it yourself. Okay, so try that, and we can do it tomorrow. So I think we have 10 minutes. Do people have any questions so far?
You said you will be checking for the code snippet to import the data.
Oh yeah, I actually, yeah, just a minute. I should probably have it. I'll just share that with you right now. So you need it for CSV to SQL, right?
Yeah.
So just for everyone's context, this is why we want you to practice on multiple data sets, but generally data sets are available only in CSV files, right, or Excel files.
Mm-hmm.
So basically, I'm just providing you a snippet where you can quickly put a number of CSV files and convert them into an SQL database. Okay, so there are prerequisites here, so I will show you how to do that, and then you guys can do it yourself, right? So table. Can you do me a favor? Can you guys drop me your email IDs in the chat? What I will do is I'm creating like a GitHub repo where all this thing will be there. So I'll give you access as well. Plus, sometimes it will be easy to kind of share these snippets as well. Create a file. Okay, SchoolDB with the database name. Here. creator. So I'll walk you through the code as well and scores. Okay, so let's do this in like a folder so that starting says CSV2 SQL. Okay, let's put it here. All right, so create a folder, call it anything. I'm just giving you the steps. Create a folder, call it anything. And this is the code snippet. So what you need to do is create a file with a name, like school.db in this case, right? In this example, it is school.db.
So it's basically like creating a database, whichever name we want, right?
Yeah. So okay, so I'll just call it new school.
Mm-hmm.
.db, right? So once this file is created, just run this. Okay. You need to put the CSV file that you have, right? So for me, the CSV file is let's say student.course.
Mm-hmm.
So you need to have the CSV file as well in the same folder. Okay. So as you can see, I have the CSV file here, student info and student scores, right? So here, and let me. Okay. So create table 1 and then you have create table 2. So first step is create this manual file. So we have already done it. So we have a new school DB. So you need to say new school DB. So the name should match exactly. Okay. Then whichever file that you have, CSV file, the exact headers, right, you need to put here. By the way, create statement we will learn tomorrow. So I will explain you. But for now, this, right, ID,
Okay.
whatever are the column, you just need the column, you need to replace the column names here and you need to give a type, whether it is integer, text. This will learn tomorrow, by the way. Section.
Mm-hmm.
This should match exactly what is there in your CSV file. Post that, just put the file name and, then the table name. So let's see, I will do a SQL Explorer to explain this. You can see here a new school DB, right? So currently your new school DB has nothing. It is blank.
Mm-hmm.
Let's run it. So let's say I'll just do one table first. Okay. So currently it has nothing. So I'll create a students table and I have a students file that I want to do. So let's run it. As you can see now, it is running and it is created. So you have does it give an error? Okay, file not found. Okay, my path was wrong. Okay, so let's do this. I will just delete this. I mean, the table is already there, so let's kind of redo this. Okay, so see, now a new table should be created. Students, right? And you have all the names. Similarly, let's say that you want to create another table. So you now the scores table. So here is create table scores. Again, the column name should match. Once they match here, ID, name, subject, and score, just do the file thing, just run it. You will see another table, the scores table. Okay.
Okay.
And I'll just say here as well that put the CSV files in the same folder. And what is the second thing? The names of the columns should be same in the create table syntax. Okay, I'll paste this in the chat. Of course, you will need Python and pandas for this. Okay. Okay. All right, folks. I actually wanted to do a join example, but I don't think we have time right now. So tomorrow morning, we will start, we'll do the same thing. You guys will work on the join examples. Like we'll give you problem statements and you will work on the join examples. That is one. And then we will move on to the other things like create, insert, and delete and all those statements. There's one more concept I want to walk through in terms of like for case state, like we have case statements, there are other statements as well. So I want to walk through that, but we can do it either tomorrow or day after. So that is all for today. Any questions for me? I know today's session was a little bit heavy, but like we'll practice it tomorrow. We'll get there, and I urge you all to kind of practice it on your own, right? You have the data sets with you, so please practice it on multiple types. Just come up with a question. For example, what is the average score of section A? What is the maximum? Who did best in section A? Right? Things like that. And practice it. We'll do that tomorrow again.
Yeah, okay.
Okay. Any other questions, folks? Any feedback on today's sessions? Anything we could have done differently? Okay. All right. Seems like we're good here. Please provide any feedback that is there. Otherwise, yeah, go ahead.
Yeah, I'm actually practicing on another database, and I need your feedback on that, if that's fine, if you have time.
Which database is this?
This is from Kaggle. It's a murder mystery database I found.
Sure. So why don't we do this, Prinsa? Share that database with the group. Okay. And tomorrow morning, we will begin with that only. Like we'll use that database to practice joins.
Okay.
Is it like one file, or are there multiple files in the database?
In the database there are multiple tables, but there is only one file.
That's fine. Yeah, that's what I meant. Sorry, multiple tables, right? So, how big is the data? How big is the file?
It's not that big. Let me check. It's like 2000 KBs.
2 MB, right? So maybe you can share it in the chat itself. We can take it or put a link and we can download it. And I think we can do that. So tomorrow we begin with practicing joins on this table or this database. And then we will move on to other topics like create, insert, and all these things.
Okay.
Okay. Please share it, and it's okay, right? We can do it tomorrow.
Yeah, I sent it there.
Okay. All right. We got it. So just let me save it. Mystery.
I can also share the link. Like they have a. So I found this data set on Kaggle, and they have a website on it, like to solve a murder.
Okay.
Like I'll
please.
send the link.
Yeah, please do share the link. I think it'll be good to, I'll go through it as well, and we can use it to practice tomorrow. And what was your, do you have any specific question on this database that you wanted to get resolved?
No, I was just stuck on a question. Like we can practice it tomorrow.
Okay, all right, that should work. All right, please do share the link.
Okay, yeah, I'm looking for the link. So basically, like you taught us like join from 2 table, but this one, I don't know, I needed like information from 3 different tables. So that's where I was confused.
Yeah, that's good. I think it's a extension of joins, so it'll be good to practice on this one. It'll be perfect that way. Okay, I can't see the link yet. Have you shared it?
Hmm. Yeah,
It's okay.
listen.
Okay, got it. Okay, got it. All right, so folks, I think it's a good heads up for all. So this is the data set that we'll be using tomorrow. So please get familiar with it, and we can. And this is like a SQLite database. So please get familiar with it, and then we can start with this tomorrow itself. Okay.
Okay.
Okay. All right, folks. Have a good evening, good night, and I'll see you tomorrow then.
Sure. Bye.